So first off, reviewing a little bit what we did cover and then finishing out Theorem 510 and 511. What we have with Theorem 5.8 is if two lines are parallel, then every point on one line will be equidistant to the other line. Theorem 5.9, if you have three parallel lines that cut off congruent pieces on one segment, or transversal, they will cut off congruent pieces on every transversal. So if you know that AB is the same length as BC, then you know that DE will be the same length as EF when the lines are parallel. Theorem 510 is where we kind of ended. What we have is a line that contains a midpoint of one side of a triangle and is parallel to another side will pass through the midpoint of the third side. And to make this proof, if we just draw a third parallel line that goes through that vertex B, then we have Theorem 5.9 perfectly. Three parallel lines that cut one transversal into congruent pieces. So since BD equals DA, DE must equal EC. And that was our proof over there. So now we're on Theorem 5.11, which uses this theorem as well as Theorem 5.9. So Theorem 5.11. The segment that joins the midpoints of two sides of a triangle has two properties. Number one, it's parallel to the third side, and number two, it's half as long as the third side. Yes. Now, the proofs of this first one, especially number one, the way you show that it's parallel to the third side is you show that by Theorem 510, there is a line that goes through the midpoint of one side and is parallel to a second side that will pass through the midpoint of the third side. So when you know you have a line that goes through those two midpoints, since there can only be one line through the 2 points, that must be then this line right here, DE. So we know automatically by Theorem 5.9, DE, or 510, that DE must be parallel to AC because there's only one line that goes through the 2 points. And that line goes through both midpoints, so we must be talking about the same line. So the proof for Theorem 1 comes kind of as a direct result. Let's go ahead and draw our diagram. So we have triangle ABC again. And we have two midpoints, D and E. And we have a segment that joins those midpoints of these two sides of the triangle. So our given information is that D and E are midpoints of segments AB and BC. What we want to prove then is two things. Number one, DE is parallel to AC. Number two, DE is 1/2 the length of AC. We talked about how we would get number one. So in proving number two, what we need to do is work with a parallelogram somehow. Since I know DE is parallel to AC, to form a parallelogram, what I need is a line through E that's parallel to BA. So when I draw that line right there, I am forming a parallelogram. So we're going to be working with that line when we do the proof of here, the second part here of Theorem 511. So for part one, putting in words what we talked about, since by Theorem 510 there is a line that goes through the midpoints G and E and is parallel to AC, and since there are only 2 points, there is only one line, DE must be parallel to AC. Now for the proof of part two again. For the proof of part two, when we draw a line through the midpoint E that's parallel to segment AB, we're drawing a line that matches Theorem 510 again. And so I'll call this point where this line crosses AC X. So when we draw EX parallel to AB through midpoint E, then what I know, here, you guys are paying attention because it does not look like sophomores work.
No, it said results this far.
Yeah, but I think it was through the 19.
Oh, there you go.
I think you guys were.
Oh, I was gonna just like do the top down.
Oh, cool.
Well, I don't know how that works, but I think you should think about that a little earlier. Okay, so now, back to finishing up part two here and gathering your attention. When we draw this line parallel to one side of the triangle through a midpoint to another side by Theorem 510, it has to pass through the midpoint of the third side. So x must be the midpoint of side AC. Now this means that AX has to be half the length of AC. And since we have a parallelogram and opposite sides are congruent, if AX is half the length of AC, then DE will also be half the length of AC. And since I'm talking about length, I won't put a segment bar over that. So quadrilateral ADEX is a parallelogram. DE then has to equal AX, which is half of AC. Into the proof to part 2. Alright, now when we have this specific diagram we just looked at, we know a lot of information about that type of figure. So when we have a triangle that has a segment that's joining midpoints, and they give us some lengths, for example, they tell us that this length down here is 14, then we know that this segment that joins midpoints has to be 7, which is half of 14. We also know that this segment has to be parallel to that segment, which makes corresponding angles congruent. So these angles will have to be congruent to the corresponding angle. We also know that if we have a triangle where we have one midpoint and a line that's parallel to another side, that if this length right here is 8, then this will also have to be 8, because that line has to pass through the midpoint of that third side. So when we go to the book on page 180, if you could go to page 180 with me.